This is under our SR flip-flop. For SR flip-flop, you can see this one. Wait, I changed the pane. So you have S equals to 1, R equal to 0, flip-flop set on the positive clock edge. If already set, is remain also set. It's just similar what happened in the example also. And for S, 0 R1 flip-flop will be reset on the positive clock edge, because you need to also refer to the truth table of your latch. You can see that for your SR what happened and etc. So it will remain a reset. If it's already reset, so it's remain reset. While for your input S0 R0 flip-flop does not change, which is remain the same. If set, it remains set. If reset, it remain reset. So this is the truth table for your flip-flop SR flip-flop. So please remember the behavior of your SR flip-flop. Similar to all the latches and also the flip-flop, you need to remember the truth tables. So this one is about your clock transition from low to high. So whenever like this, you're going to get your output level priority to the clock transitions. Later on, you're going to see also the high to low, what will happen. So this is another example under our SR flip-flop. You can see you have the clock and you have the output. Please try to do it, because the output will be already given. This is the positive edge trigger, as we already also discussed. So I hope that you're going to fully understand on the basic things. Now also you are given the example, find the waveform for Q and Q bar. Of course Q bar will be it is over here. Your Q bar will be the toggle versions of your Q, right? Assume that the positive edge trigger flip-flop is initially reset. So what is the meaning? So initially it's reset, that your value is starting from 0. So from 0, and then you need to check from your clock. So you need to draw the dotted like this, as I already mentioned. But your dotted will be at your clock. And also when you can see over here, the clock only, because this one under flip-flop. But for your end, you're going to draw over here also, because while the value of 1, you're going to also consider your input, but it is under latches. Now we look into our flip-flop. Please make sure you can differentiate between clock and en. So please, maybe you can put another one over here under your en. So please try to draw also the SR latches output. So it's going totally different with your output for your SR flip-flop and also your latches. So over here you were given the answer. As mentioned, it will be starting at 0. And what happened over here is depend on your value, 0, 0. So you refer back to your truth table. 0, 0 is no change. So that's why you will get like this, and until the next value of clock. You can see over here, this one is 0, 1. 0, 1 will be reset. So reset is 0. So you remain as 0 or reset until the next clock over here. It is value of 10, it is set. So you will be up until the next clock trigger. You're going to have over here 01. You're going to get a reset and follow until here. So you can see it's quite easy for flip-flop because you just look into what happened the inputs SR where at the clock trigger. But if you have latches, let me draw something. If we consider it as N, I repeat again, I just consider it as N. So the input is 1 1 1 over here, because this is N and the rest is 0, of course. So what happened, you're going to get your output in the N if 1. So over here you can see the first thing happened at here, it is 0 0. Of course it's going to remain until over here there is a changes for your inputs while your N is 1. So you need to check it is 0 and 1. 0 1, it's what? I forgot to travel. If 0 1, let me check. 0 1 0 1. Okay, over here. If 0 1, it will be reset. So you will follow like this until 0 0 1. Okay, until over here. Then it will remain the same and until you have another the value of 1 over here, and you have this dotted also. First you will get 0 1. 0 1 is reset and it will change another here, it is 0 1 0 1 0, it will set. So it will be like this until this one. So over here you will see there is 0 1 0, you will remain the set, and you can see it is 0 1 over here, starting over here. So you will be having like this and etc. So you can see from the start over here you have the difference of the output if it is a latch, and this is the output for your flip-flop. Totally different because it is AND and also clock. Please try to do both AND and clock for this question. So next is the example also. This one is how you're going to represent it from your timing diagram. So you just draw the tables, what happened for your clock 1, 2, 3, 4, 5 and 6. What is the output? So 1 Q is determined. Q bar is easily found since it is simply the complements or the toggle versions of the Q. This one I already mentioned. So next is our D flip-flop. Our D is a data or delay. So D flip-flop is useful when a single data bit, which is 1 or 0, is to be stored. So when you're going to store the value of 1 or 0, so the additions of inverter or NOT gate, you can see over here, to an SR flip-flop create the basic D flip-flop. This one is also similar to your lectures, so no need to focus more, as if you already understand in your lectures, it's quite similar. Only the difference at the clock. so nothing much different. And you can see the truth tables also quite similar, only at the clock different, which is for your latches you have EN, but under flip-flop over here it is clock. And the output is similar for the value of D. So please try to do it so, because it is just a repetitions from what happened to your lectures, only the different at your clock. Over here at your clock, when you trigger your clock, then you will see it will trigger also. So you can see over here, assume that initials is reset or low, so you will trigger, and the rest you no need to see at all. You will see only over here. So when over here it is 0, then you will go to 0 and remain the same. No need to see whatever inside here. And you will change after that. You copy paste whatever value here until the next circles of your clock. Is it okay? So I think flip-flop much easier from your lectures, because you just depend on your clock. So this one is your JK flip-flop, which is quite different from your lectures. It is out of scope, which is the different on the JK, and the circuit also different. So you need to know that inside of this you have the different version of circuit, but totally you're going to be show only these symbols. Inside of this you were given this circuit actually. So let's take a look over here. JK has no invalid state as SR. So SR for your lectures, for your flip-flop, you can see there is invalid output, isn't it? Or invalid states. But for JK there is no such thing, and all the output will be get the output depending on your input. So all the inputs variables will be get the output. So over here, this is the truth table. Please remember it. You can see this is the meaning of O, whether it is the positive edge or negative edge. It depends. If let's say the question's asking you to have the positive edge, which is clock transitions low to high, so you can also consider it low to high. This one is low to high, sorry, low to high, this one, and this one is high to low. So this is supposed to be here. So the output level priority to the clock transitions. So over here you need to know it is to travel for your low to high, and you can see the output, no change, reset, set, and toggles depending on your input. So you were given the clock over here, and you need to know that you have another two input, J and also K. Let's take a look into it. Let's say over here you have clock, this one you have another one, and then another two, 3, and the rest. So you have 1, 2, 3, 4, 5 until 9 clocks. And you can see over here, this one is your positive edge. So you can see when you have this part, you're going to have the value of previous. But you can see over here you also have the high to low. When it's having like this, you need to also look into your JK, which is at this part it is 0 0, which is no change, remain this change until over here you have also 0 0. Sorry, it is 0 1. So 0 1 is reset, and over here is 0 1 also, it's reset, and until the next this one, your clock, you can see over here the value is 1 1. So 1 1 it will be toggle. So toggles mean from the previous output should be a toggle, but this one I think it just show you for the low to high, but over here should be if it is 1 1. If let's say you have the high to low, you're going to toggle, then you're going to be having like this. But in your diagram over here, it just look into your positive edge, which is like this, which is low to high. That's why you're going to have toggle at here, and try to do rest. But this one is, I already mentioned again, it is only low to high, but your clock to table you can use for both. This one is scenario for you to have the low to high. Depend on the question, it should be mentioned to you about the clock, whether you have the positive edge or you have the negative edge, or also maybe you are given the low to high or high to low, depend on the questions. So positive or negative edge, as I already mentioned. So you can see over here, if it is negative, you will be change at here, but this will be a positive because you change at this clock. So over here you can see there is another example, please try to do so, and here is the output, but it's also mentioned over here whether it is positive or negative edge. You can see the output. When you get this, then you know what is the edge. So it is a positive trigger or positive low to high. What else you need to know? I think it's quite similar like all that I already shows. So try to do your examples, all the example here. You were given this one. You can see also at this part, as I already mentioned about your clock. When you look into your clock over here, you know this one is positive trigger for your clock. That's why you will consider this part. When you are here having this bar, I think this part I already shows in our previous slide, so please look back your previous notes. So this one will be a bar and it is negative, so that's why you will pick the negative side, which is from high to low. So similar to your T flip-flop, T is toggle, so it's quite different because it's only have one input. Another one is your clock, of course. So frequently it used in building counter. So this is what the logic symbols, and the truth tables were given. So you have the clock over here, your output and also your input, what we're going to happen, and basically it's quite similar. If your output last time is 0, you will be having 0 also, and etc. And over here you can see that the timing diagram for T over here, this is the negative and this one is positive. So you can see over here, this one is negative, so you will look all from high to low only. Then you draw represent from your truth tables. And another one is our FF asynchronous input. Synchronous, which is input transfer on the trigger edge of the clock. And synchronized is input effect the flip-flop independence of the clock. Normally labels depend on the manufacturing. So there is a difference, which is preset and also clear. You can see over here. And this is your flip-flop, and you need to know the modes. So where you're going to put your preset and clear, so this is where you're going to put and add your preset and clear. So what is the difference? So this is the truth table for preset and clear. What happened, it is normally like also there is another two input, which is input preset and input clear. So you need to see the priority. Highest priority is when preset and clear and synchronized input. You need to see this input first. Second is your clock. Previously, you need to check your clock first, then you will refer to your input, isn't it? So this is your normal input, S, R, J, K, D, and T. And you will trigger your output only depend on your clock. But when you get another one, which is asynchronous input, which is preset and clear, you need to check this first. After that, then you can look into your clock, and lastly your input SR. So flip-flop and synchronous input has the highest priority, which means that the asynchronous input active, the output will immediately change regarding the value of synchronized input or clock. There are two types, which is preset and set. Preset to set initial value to 1 to the output, and reset the output to be 0. So it's quite easy for understanding because it is totally direct, which is if you preset or it's called as set, you're going to get the value of 1 for your output, and clear is when reset, so your output will be 0. So what happened? This is the example. So first of all, you can see you have clock, preset, clear. Last time you look at the clock first. Okay, as this is positive clock, you need to see your clock at from 0 to high only, from low to high, from low to high. And maybe you can draw the dotted also at each of the clock transitions. And assuming Q is low first at initial, and you can see whatever happened to your preset and clear. So you might refer to this one. So you can see first of all, you have preset 1 and your clear is 1. So if you have 1 1, you can see that it is synchronized for your flip-flop JK. And you can see the what is this, your clock over here is not yet triggered, but your inputs already trigger for your preset and also your clear. So if your reset and preset over here, you can see 1 1, so like this, you will be having the preset. This is the preset if it initials value to 1. So you need to follow the sequential priority, which is you will pick the preset first, which is 1 1, and then later on you look into your JK synchronize. First you pick the preset, so you're going to do the output as 1 pen on here. And then after that you can see that it's always remain until you have another 1 clock over here. So the value of your preset and clear is 1, this one is 0. But normally after that you need to always see that your JK over here, it is high, means that it's always 1. The value is always 1. That's why over here when you have 1 1 for your preset, you need to follow your JK input, right? So that's why you get 1 high. And then for your clock over here, it is 0 1. 0 1 0 1, so it will be set. So that's why it still remain set over here until the next clock. You can see also over here the value of your preset and clear 0 1, so it will remain like this. Then you have the change at your preset and clear. You can see your clear is 1 and your preset over here is 1 also. So if it is 1 1, as always you need to look into your JK value. It is 1, which is high, so you will remain high. And you can see another clock over here, it is 1 1 also, but this one is your clock. You can see the clock is having, so it should be a remain. So next is you going to have, I think over here 1 1. So later on at your next clocks, you can also have your 1 1 over here. Your clock depend on your clock at this stage, so you need to look into your value of your JK. For JK, where is your JK flip-flop? So it's quite complicated because you have JK, you have also the clock, you have also the preset, and etc. So JK over here, you can see the value of JK. If it's 1 1, so you will having the toggle, isn't it? It's depend on the clock, but you can see what happened. I show you again. Where is it? So if you don't understand, please make sure I will explain it in class, but on the request. Where is it? Where is it? Okay, this one. So you can see, I clear it first. At this stage, you can see that this is 1 1, depend on the value of preset and clear. So that's why you need to check these truth tables. Value as 0 and 1 1. So the output will be look into your JK value. So for your JK, you can see the input is high. So that's why you will get high like this, which is your called as your preset. It's depend on your preset. So that's why you will follow until the rest. But throughout over here, you can see your clock also. Your clock, your pre over here, you have 0, 1. So what is the next important is your value of your clock as mentioned. So you need to check also your clock, but you need to check the highest priority. First, if pre, second is clear, and then third is clock. So you need to see the now about your clock. So your clock, you need to refer this through table. Where is JK? This through table, like this. From here. So what is the input? Where is it? Okay, so you have this one for your clock, but it will remain the same when you have the pre set which is 0, and then your clear is 1. So your flip-flop will be at the set. So see over here, it will set which is value 1 until the next. You will get similar until these changes on your preset, and also clear. Over here you have 1 1 1 1. You're going to depend on your JK flip-flop. This is the part whenever you have 1 1 for your preset, you're going to look into your clock. Over here, you no need to see your clock on your truth table JK, because you need to always depend on the value of preset, and this one is your output. If preset is 1, your output will be reset. If your preset is 0 1, you're going to have set. But when you have 1 1, you're going to get your JK truth tables. Later on, if you not understand, please make sure you ask me in the class. So that's why over here you're not going to consider your clock, and because over here your preset and clear is 1, so you need to consider your clock, because you need to refer your JK flip-flop. So that's why over here you need to see if it 1 1, you will still do the reset things, which is the value of your JK is high. But when you have the changes on your clock over here, you need to see your JK flip-flop truth tables. If it's 1, it's going to be toggle, so it will toggle the value of your JK input. So you can see over here, this one is high, so that's why you're going to be toggle from your previous output. So it's be toggle, and then after that over here is similar also. You will be having the toggle if it's 1 1. If not sure, I also not sure. So you can see over here JK is 1 1, and it will be toggle. Why JK is 1 1? Because both of your JK over here are connected to the same input is 1, value as 1 1. So that's why you're going to get toggle for your output. Toggle from where? Toggle from your previous output. Is it okay? So until here, you're going to look your clock until the value of 1 1 only for your preset. But after that, you can see the value is changing 10 for your preset. So you no need to look into your clock at all, because the priority for your preset and clear truth table. So that's why you will consider this part only, whether it is set or reset for your output. Is it okay? So two truth tables you're going to refer if you have these FF and synchronized input. First truth table is this one, and another one is your JK flip-flop truth tables. Depend on what flip-flop you are having. So this one is, yes, what happened. This one is the explanations, and you can see there is exercise, so you can try to do it also. It asks you about positive or negative edge. You can refer to the symbols at your flip-flop, and yes, you can see that you only consider your clock when it's having the 1 value for your clear and preset. So please make sure you understand it, why you not consider your clock here. And this part, where is my microphone? Okay, next, this is solutions. This is another exercise. Please try to do so. I think it's just as simple. Only that maybe you think that what is this, you don't know about your JK and K, what is the pin. Maybe this one we're going to discuss in class also, but please make sure you ask me, if not I'm going to forget. And another one is on your extra notes. This one is under master / flip-flop, which is JK example. You can go through and read it. This one is under master / flip-flop. You can read it all through together, but it having the also truth tables. This one is for JK master, but basically it's similar, same to your logic gate also. It's depend on the truth table and the behavior of the gates, right? So please try to do it. So we already cover our module 7. Tomorrow in the class we're going to look into our module 8. So hope that you have the fully understand and strong your basic first, then you can move another chapter. So thank you for your watching this video. I really appreciate it, and please make sure you understand and study. Hope you're going to get excellent marks for your digital logic subject. Thank you. Bye bye.